Hello everyone. This is lesson 36A. It is notes for 36A. You will notice that on the screen right now you see a picture, and this is a PowerPoint slide. So the lesson that we're doing today is all about how to look at a graph and interpret where the graph is increasing, decreasing, and constant. So if you take a look at our graph right here, you'll notice that it looks like a V. When we do increasing, decreasing, and constant, we always go left to right like you read. So if I start on the left and go right, do you notice that our graph is decreasing or going down until we hit the bottom of the V right here? So it's decreasing or going downhill. Then it's increasing or going uphill. Okay? And there's never a place where it's constant, where it's flat. So if you take a look at our slide, notice it's going downhill because you're going left to right, downhill, and then it's going uphill. So downhill is decreasing, uphill is increasing. Okay, then we have another picture. So the first picture was decreasing and then increasing. Okay, the second picture is the opposite of the first picture. This second picture is increasing. See how it's going up from left to right till we get to the top of our little U, and then it's decreasing. So it's increasing and then decreasing. So it's going uphill and then downhill. Remember again, you always have to go left to right. So if you take a look, notice it's going uphill, which is increasing, and then it's going downhill, which is decreasing. Now, when you're describing what is happening on a graph, okay, we always use the x-axis, which is usually time, minutes, seconds, hours, usually time. And what you're asking is, what happens over the first 10 minutes? What happens over the next 3 minutes or the next 7 minutes? So notice on this graph that it starts out and it says the graph shows the varying speeds at which Emma exercises her horse. The horse walks at a constant speed for the first 10 minutes. So the constant speed, see, it's that flat line for 10 minutes. Okay, then its speed increases over the next 7 minutes. So notice how it's going up, it's increasing from 10 minutes to 17 minutes. Okay, then it gallops at a constant rate for 20 minutes. So the horse is galloping at a constant rate, not speeding up, not slowing down, going the same speed for 20 minutes. Then the horse slows down over the next 3 minutes. So it slows down from its gallop, and then finally it walks again at a constant pace for the last 10 minutes. So the horse walks, then increases its speed, then gallops for 20 minutes, then decreases its speed, and then walks at a constant rate again. So increasing is going up from left to right, decreasing is going down from left to right, and constant is flat, horizontal. Okay, now we're going to go into My Open Math, and my computer went off. There it is. And we are back. Okay, escape. I don't know how that happened. Okay, now make sure that you're in notes for number 36A. Notes for number 36A. So if we take a look at this graph, okay, if we take a look at this graph, left to right, remember you always have to go left to right. So if I start on the left, notice that I'm at -7 minutes. And then if I go to the right till my first dot right there, notice I'm at -3 minutes. Now, going left to right, do you see how that graph is going uphill or increasing, and that it's curvy? So it is not linear. Okay, so we're going to say that from -7 to -3, the function is increasing and not linear. Okay, then the next section of the graph, the next section goes from -3 right here to 1 right there. And if you look, can you see that it's increasing? And this time it's a straight line. So it's increasing and linear. So increasing and linear. Okay, now the next section goes from -1 to 1. And notice that it is decreasing. It's going downhill and it's linear. So decreasing and linear. Decreasing and linear. Okay, now the next section goes from 1. Notice that each section starts where the last section ended, to 3. And it's increasing, but this time it's not linear anymore. It's curvy. So it's increasing and not linear. So increasing and not linear. Okay, the next section is from 3 to 5. And notice that it is going downhill and it's not linear. So it is decreasing and not linear. And then the last section is going from 5 to 7. And notice that it's straight across, so it's constant. Constant. So we have increasing and not linear, increasing and linear, decreasing and linear, increasing and not linear, decreasing and not linear, constant. And then we submit. Number 2. Okay, so on number 2, now we have to fill in the numbers. Okay, let me make my picture bigger. That makes it better because you can see it better. Okay, so I need to know from what time to what time what is happening. So if I look right here, this is the beginning of the graph and that's the end of the first section. And if we look down here, this is at 0 and this is at 2. So from 0 to 2, okay, and if we look at it, can you see that it's increasing? Okay, so from 0 minutes to 2 minutes, it is, from 0 to 2 hours, so not minutes, hours. The function is increasing. Function is increasing from. Okay, now it says the function is decreasing from. Okay, where is the function decreasing? So if I go look at my function, it is decreasing from here to here. So this is 8 hours and this is 11 hours. So it is decreasing from 8 hours to 11 hours. So from 8 hours to 11 hours, it's decreasing. Okay, then where is the graph constant? Okay, well, the graph is constant from 2 hours to 8 hours. See how it's straight across? So the graph is constant from 2 hours to 8 hours. So it's always the time when you're on the x-axis, okay? So from 0 to 2 hours, it's increasing. From 8 hours to 11 hours, it's decreasing. And from 2 hours to 8 hours, it's constant. And then we submit. Number 3. What does the graph below show? Well, if we look at the graph left to right, the graph is increasing and then constant and then increasing. So it's increasing and constant, but there was nowhere where it was going downhill. So it's not decreasing. So it is increasing and constant only. Submit. Number 4. What does this graph show? So I start on the left. It's increasing because it's going uphill, decreasing going downhill, increasing, going uphill. So it's increasing and decreasing, but there's no flat, so it's never constant. So this one is increasing and decreasing only. Submit. Number 5. The graph below represents the total profit in dollars over the time in months. From month 0 to month 1, the function is, and we have to say if it's increasing, decreasing, or constant. So from month 0 to month 1. So month 0 to month 1, can you see that it's going up? It is increasing. Okay, from month 1 to month 2, from month 1 to month 2, can you see that it's constant? Now from month 2 to month 5, from month 2 to month 5, it's going downhill, it's decreasing. And then from month 5 to month 7, month 5 to month 7, it's increasing again. And then we submit. Number 6. Okay, this is the same type of a question that we just did. The graph below represents the temperature change in degrees over time in hours. So the time is on the x-axis. I told you on these graphs, it's almost always time on the x-axis. So from what time to what time is the temperature increasing, decreasing, and constant? Okay? So we're going to start from left and move right. So if we look at the beginning of our graph, we are at 0 hours, and then our next section is at 1. So from 0 hours to 1 hour, the graph is increasing. So from hour 0 to hour 1, the graph is increasing. Okay, now we're at hour 1. From hour 1 to hour 3, see how it's constant? From hour 1 to hour 3, it's constant. Okay, now the next section, from hour 3 to hour 5. So I'm doing each section of the graph. It's going downhill, so it's decreasing. So from hour 3 to hour 5, it is decreasing. And then the last section of the graph, from hour 5 to hour 7, it is going uphill, it's increasing. So from hour 5 to hour 7, it is increasing. And then we submit. Number 7. Okay, this last 2 questions, we are going to draw the graph, okay? So it says Noah parked his car in the supermarket parking lot and walked into the store. It took him 2 minutes to walk 40 feet into the store and to the customer service counter, where he waited in line for 1 minute to pay his electric bill. All right, so that's 2 sections on the graph. It took him 2 minutes to walk 40 feet into the store. So we're going to start our graph at the bottom, and he walked 40 feet, and it took him 2 minutes. So we put a dot right there. Then it says he waited in line for 1 minute to pay. So we put a dot right there. Okay, now we're on the second bullet. Next, he walked 60 feet to the back of the store to get 2 gallons of milk, which took 3 minutes. Okay, now he walked 60 more feet. Okay, so if we're at 40, we have to go up 60. So 10, 20, 30, 40, 50, 60. So he walked 60 feet to the back of the store, and it took him 3 minutes. 1, 2, 3. Then he walked 70 feet to the checkout near the front of the store to pay for them, which took 2 minutes. So he walked 70 feet to the checkout near the front of the store. Okay, so we have to go back to the front of the store. 10, 20, 30, 40, 50, 60, 70. And it took him 2 minutes. 1, 2. After waiting his turn for 3 minutes and paying for the milk, okay, he waited for 3 minutes and then paid for the milk. He walked 30 feet back to his car, 10, 20, 30, and it took him 2 minutes. And that is our graph. Now, if you're having trouble with that, rewind the video and watch it again. Okay? Number 8. So this is the same question that we just did, just a different scenario. So Angela is babysitting and buying a sandwich. It took Angela 1 hour to travel 30 miles from her house to Joe's house, where she babysat for 2 hours. Okay? So it took her 1 hour to travel the 30 miles. So we click right here, and we went 30 miles in 1 hour. Okay, then it says she babysat for 2 hours. So she stayed there for 2 hours and babysat. After eating her sandwich, she returned home, which took 3 hours. So she went back home, and it took 1, 2, 3 hours. Oh, I have to click it again. So she traveled 30 miles in 1 hour. Then she stayed where she was for 2 hours babysitting. Oh, wait a minute. I'm bad. Let's clear that again. I missed a whole part. Okay, she went 30 miles in 1 hour. She babysat for 2 hours. Okay, I missed the second bullet. After babysitting, she traveled 50 miles in 3 hours to a deli, which was further away, to buy a sandwich. She spent 2 hours there eating. Okay, so she traveled 50 miles in 3 hours to a deli. Okay, so she went 50 miles, 10, 20, 30, 40, 50, and it took her 1, 2, 3 hours. Then she stayed there for 2 hours eating at the deli. And then she went all the way back home, and it took her 1, 2, 3 hours. My bad. I'm so sorry for that mistake. And then we submit. And now you are done, and you are ready to go do homework 36A. Have a great day. Bye-bye.